Hi, in this video, I'm going to take you guys into the topics about the memory profiling, specifically in Golang, and explain a little bit about the garbage collections. Okay, so before we jump into those topics, so we have to understand why do we need the profilings and what is the profilings itself first, right? Okay, so a profiling is a process when you want to analyze the performance of your running software by using a tool called profilers. So there are like many types of profilers, but basics profiler are consist of like three types. First is CPU, second is memories, and the third is a network. Because these three are like basic computer components. Okay, so for the CPU profilers, so you when you want to see which part of your application is taking the CPU times to compute, so you will use the CPU profilers. And when you want to see which part of your application is reserving how much the memory, you can use the memory profilers. And of course, in this video, I'm gonna covering the memory profilers, but I highly suggest you to also look into another types of profilers also. Okay, so let's talk about the problems that usually lead you guys to do the memory profilings, the memory leak. So the word leak is actually like the water leaking from the pipe on the left hand side. Um, if you have these situations happens, you lose the water, right? You lose the water from the system. But for the memory leaks, you don't actually lose any memories, but instead, it is the symptoms that when some parts of your program is reserving the memories and it's not returning it back to the memory pool, which caused the available memories in the memory pools getting least. Okay, so what will happen when there is no available memory to start another process or even compute the current process? It's gonna cause like the system to goes down. Okay, so which is not good. So let's see the example, the signs of the memory leaks. Okay, so here is the graph that shows you the memory consumptions from a service that's running on the production's environment. Okay, so on the x-axis is the memory usage, and on the y-axis is the times. So I would like you to see the green graph, this one. Okay, and you compare it to like this point and this point, so you can clearly see that the memories never goes down to the point where it was before when the times goes up, and the trends of the graph seems to be like goes up more and more. Okay, so this is the signs of the memory leak. Remember, the definitions of the memory leak is you reserve the memories and you never return it back to the memory pool. So moving on to the next part about garbage collections. Okay, so in the higher level languages, it includes this part called garbage collections in the codes. So this is the code where it scans all of the objects. So to see whether it is required by your code or not. So if it's not required by your code, it's free that part of the memory automatically. Okay. In the memory, there are two types of memory. There are stack and there's heap. Okay. So for the stack, of course, it is as its name, right? So it is when you call another functions, you create another stack and push it into the stack, right? Okay. So this part of the memory is not actually take need to be taken care by the garbage collections. So because when you return from that functions, the memory is automatically free by the natures of the stack. So here, when you return from this code, so you return into this stack instead. Okay, this part of the code is getting freeze automatically. Okay, so for the stack, it is easier for the memory management. So no need to care. Okay, next is heap. So this is the problem. So the heap is actually like a dynamic memory allocations. So when you say that malloc or dynamic allocations, so everything is going to be reserved in a heap, and this is going to be the problems. And this is where the garbage collection will comes to fix the problems. Okay, so let me draw you this rectangle scene. You may look this as available memories. So imagine that you have code from functions A that reserve this part of the memory. Okay, and then after you done the stuff in the functions A and you return it, and next the function B is gonna take part, okay, here, and functions B is doing something and it reserves some of the memory, okay, and it's returned. So in this example, you might see that the code from the function A here, the data is in the memory never gets free. Okay, so the garbage collection will sweep this memory to see whether if your current codes can access this part of the data or not. So for example, if I return from the function A to the main and the main access the function B, so it means that something that has been declared in the function A cannot be accessed anymore. So the garbage collection will mark this parts of the memory that it needs to be freed. And then in the sweep phrases, it's going to be freeze automatically. So this is how the garbage collections work. So the key takeaway is that it will free the memories that cannot be accessed by your codes anymore. Okay. Okay. So let's jump back to the slide. Okay. So as you can see, this is why you still survive nowadays when you are writing the higher level languages. So by using the garbage collections, well, let's head to the coding part. Okay, this is where the fun begins. So we're now in the code. So this code will demonstrate you the way to do the memory profilings in Go by using the pprof tool, which is the built-in profiling tools in Golang, and the memory leaks problems, and lastly, a little bit about the garbage collection that I have covered in the last part. Okay, so this is the example program that I developed. So it's actually a normal HTTP server which serve the slash example part in the post method. So let's take a look into the handler functions. So I'm using Gins as a HTTP server framework. Okay, so let's jump in. And here, it's a simple source code. So first, I get the header, which is the X request ID, and then I insert this key into the context with the value as the request ID. So just to quickly recap, so in Golang, we have a concept called context to pass down into a downstream functions to create a different behavior. So for example, I create context by using this method, and then I want to add the keys and value into this context. So I use the context with value and pass down the parent's context and keys and values and set it back to the same variable. And then I get the variable by using the same key that I just set it by using this method. And then I print it out. So the expected result would be hello world. Okay, so since the value is a hello world, okay, obviously. Next, I would like to show you another example. So when I wrap, when I insert the value with the same key, the expected behavior is that it's gonna replace the same the value that I set it before. So in this case, it should be like test2. So let's run this program here. As you can see, is if I get the same the value from the same key, I get the different value based on the latest value that has been set to this context. Okay, so let's jump back to the code. Okay, so I use this method to add the value. In this case, is a request ID into this context. So I'm gonna tell you why I use this context from this struct and later. And next part of the software is I create two Go routines to simulate, like we might want to do the database connections or some tasks that we might want to do in these two Go routines. So we pass down the context and we print out the uh, request ID, and then we just wait for them to finish. I mean, these two Go routine to finish itself, and then return the request ID back to the caller with the status OK or 200. Okay, so let's get back to the part why I use this context instead. Okay, so because in this part of the programs, I wanted to do the gratefully shut down features, which is when you got a shutdown signal, you want to cancel every request inside of your applications completely before you shut down the software. Okay, so I create the context and wrap it with the context that would cancel. So here, when I got the cancel or I got the shutdown signal, I call the cancel to make the context cancel. It's actually I have to wait for some time to make sure that every Go routine is shut it down correctly. But just to demonstrate you in this video, okay? So, and then I pass this context inside of the handler struct, and then I use it in the handler functions. Okay, so this seems to be a normal program, right? Let's start it up. Okay. Oops, sorry. Okay, so here I started up the program, and let's demonstrate you a little bit. Okay, the expect is that I should get the response as the ABCD. Okay, so as you can see, the ABCD here, and then on the console, I should get these two lines printed from these two Go routine. Okay, so the application is work as expected. Okay, so to visualize whether there is a memory leak problems or not, first you must have a visualize on the memory consumptions of your software first. So in this video, I'm gonna use the Grafana monitoring stack. So this is the Grafana running in the Kubernetes, and I already built my software and push it to run in the Kubernetes already. So I run it in like a couple of hours, and the memory seems to be stable at 9.4 megabytes. Okay, so remember these numbers, and I'm gonna create a simulate load tasting, okay, by using K6. Okay, K6 is a software to do the load tasting. Okay, let's start the load tasting part. Okay, so this is gonna take some time. So I would like to explain to you why I have to do the load tasting, because the memory leak is not actually the problems that you can easily spot, because sometimes this kind of the problem may be visualized after there's a load on the productions, and you can see that is a difference the memories that you allocated. Okay, so the load testing is complete. We sent around like 30 to thousands of requests to our server. Okay, so let's take a look into the Grafana whether we have we will see some memory difference or not. Here we can see is that our memories goes up by almost 100%, right? So you can see that the memories goes up from 9 megabytes and to be like 21's around 21 megabytes, and it seems to be stable at 21 megabytes. So this graph is actually showing you that we might have memory leaks problems. So actually, that program that I show you actually have the memory leaks problems, but in the real world situations, you might not easily spotted it, because this is only takes around like 2 minutes to see the difference in the graph. But on the productions environments, it might take a day or a week before you can spot this graph. Okay, but let's jump back into our example. So now we see that the memory is stable on like 21 megabytes, which is different from the start, which is 9 megabytes. So to track down the problems in this case, you have to install the profiling tools, because when you look at the code, you don't get any information whether why your code is leaking out the memories, right? Okay, so to install the prof tool, you have to you can do it in many way. Okay, you can do it by using the manual codes that prof pprof dot write heap profile. So as I told you that we are focusing on the heap, because this is the part where we can easily leak out the memory. Okay, so we can write the current heap profile by using this code and create the file. When the code hit this function, it's gonna write down the heap profiles to this file. Okay, but to be more dynamically for us, we want the prof to be like available to access from the productions environment. Okay, luckily the prof provides you the http handler. So this is the first page of the prof. So this is the default parts of the to the prof. Okay, and then another part is heap. So I'm gonna export this to handler. Okay, and then let's run our software again to see the example. Okay, so here is the landing page of the prof tool, and you can see that there's a many profile that you can collect from the prof. Okay, but right now I'm focusing on the heap. Okay, so what you have to do is download this data into your computers and run the local visualizers on your CLI. Okay, so let's quickly copy this address, and then okay, so I already download this file, and then to start the visualizations too, you can use this command. In this case, I'm going to show you the websites of the pprof2. So I specify the HTTP server. Okay, so it said that it's serving the web UI on this part. Okay, so let's take a look. This is the first touch of the pprof2 in the websites. So as you can see, there are various of information that it's already simplified it for you. Okay, so let's go through the sample first, because this is the part that you have to select when you want to view your profiling data in a different aspect. So there are 4 different samples that you can view. First is allocated object. Okay, so let's see. So here, the word allocated means that it shows you the data since when the program started, and the objects means that the numbers of the object that has been allocated uh, since the start of the applications. So for example, this functions, so each block is a functions. So this function is allocated 16,000 objects and 32 by each. Okay. Next is the allocate space. So this is the space that has been allocated since the program start for each functions. Okay. Okay, as you can see, this function is allocated the 500 kilobytes, 32 by each object. Okay, and next is the in-use object. So this is showing you the current live object in the memory that actually being used by your software. Next is the in-use space. So this is showing the space that is being used by your software. Okay. Okay, so this is all the sample that you can visualize. Normally you would like to use the in-use space, and you can compare it to the allocated object to see the data in different aspect. Okay, next is the view. So the current view is called a graph view. The graph can come in handy when you want to visualize the memory footprints. I mean, where the functions get called. Okay, so for example, in this function is allocating this much of the object. So this function is being called by this function, and you can trace it back to the starting point. This may be helpful when you want to trace down to the root cause, but keep in mind that there can be a multiple functions that you can reuse throughout your code, right? So you have to like manually realize that which part of the code is using these functions. Okay, so when you look into the graph, you would like to see the leaf nodes, because this is where it's actually reserving your memory. Okay, for example, as I already said, because this function is reserving this memory. Okay, this object. Let's switch to the in-use memory. Okay, so and this function call these functions, and the numbers showing in the arrows means that the total amounts of the memory being reserved by this part. Okay, so when you trace it back to this node, this function is called to function, and each function or each part is reserving 500 kilobytes. So in total it's reserved like 1,000 kilobytes, and you can trace it back to this where it was start. Okay, so this is the graph. Next is tops. Tops show you the top functions that reserving the memories at that time. Okay, so In this case, is the regular expressions syntax is reserving like 15,000 kilobytes at this time, and you can switch the sample to see the different data. Okay, this might come in handy when you see something that some function that's allocating the unexpected amounts of memory. Okay, next is frame graph. So the frame graph shows you the stack of the function call, but each cell is representing how much that function is reserving the memory. So for example, let's see this syntax.parse. So this function is called two functions. As you can see, in the downstream stack is called syntax.literal and then parse vertical bars. Okay, so but parse vertical bar is actually reserving more memories compared to the literal, and the color of it doesn't means anything. It's just randomly selected to from the warm color. Okay, so this is uh, the way to visualize it. So let's see the real data. Okay, hey, let's refresh it. So this is the real data. Okay, of course, in the productions environment, you may see a lot of things going on in this graph. So let's see. Okay, so here is the main. We don't usually see anything going in this part, so just skip it. And here is where the HTTP gets served. So you can see that it serve run HTTP to serve, and then serve handler, and here is Gin handler, and this is Gin middleware. This means it said that it's taking around 2,500 kilobytes, and then go around, and then it end up here because the arrows coming up from this box is. So here you can focus, so you can click on refine and focus on that parts of the code to minimize the other parts. Okay, so you can see that something is really weird here. The context of its value is actually taking around 1,500 kilobytes. Okay, so let me tell you that normally in Golang, the context can be like big, but it should be discarded every time that request goes out. Okay, so you may you can suspect this part, but you cannot be sure because still it's maybe just a normal code because these part of the prof show the instantaneous memory dumps. Okay, maybe in the next times that you call this dump out, this part of the memory may be removed. Okay, so let's simulate another times of the huge load by using K6, and then we're gonna scrap it out again. Okay, so this is the data after another load tasted. Okay, as you can see that there can be another part that popping into the graph, but as you can see, as I expected it, so the context dot width value is getting bigger than the last time, which is the 1,000 kilobytes. This time it's now 2,500 kilobytes, which means the context dot which value is actually causing the memory leak. Okay, so let's head back to the code. The next things that you're gonna do is when you spot the problems that this is the problems, you're gonna see which part of the code is causing this. You can see that it's come from the handle request, and then origin. So this part can be ignored. So is this in is this the context dot with value within the mains dot handle request, which is this functions, and we can easily see that it is this part. Okay, so what is the problem? And trace down to the points by using the debugger. So this time I'm going to attach the debugger into my programs and call it normally. Okay, now these is getting paused. Okay, so let's see the context store the keys and the value correctly. Okay, seems not to be a problem, right? Okay, let's just continue. And then I send another request, just like when there's a many requests coming to the server. Okay, so now you see something weird about this part. Okay, so as you can see that the key here x request id and the value is abcd, which is the latest data that I just sent it here. But you also see the previous value, which is 1 2 3 4 in this case here in the context. This part is actually causing the memory leak because it's actually storing the previous request data inside of this context as well. Okay, so to fix the problem is very easy, right? You may just assign it into uh, another variable and don't assign it back to the handler. Use this as another context to pass down into the functions. Okay, let's try it again. Okay, this time query, and then see the context inside of the handler never get touched. Okay, but the context that we just created as a local variable has been added the request ID here. So let's continue. Oh, this should fix the problems, right? Mm, okay, so let's build this software and push it to run in the productions. I've already updated the deployments in the Kubernetes to run the latest software that we just fixed. So let's give it a load test. Okay, so the load test was completed. So I decided to run 2 load tests. So here's the result in the Grafana. So this is the first load test. So the memory spiked up to like 11 megabytes and then stable at this level. And then at this point, I decide to run another load test to see whether the software is actually reserving more memories, because this time it might be something that it needs to be reserved for the first time that the request coming into the server. Okay, it seems that the problem is fixed because here after the first load test the memory is like 10.5 megabytes, and then the after second test load test the memory is still stable at around 10.6 megabytes. Okay, which is pretty close to where it was before. Okay, so I would say that the problem is fixed compares to the previous revisions that the software reserving the memories over and over again until like 28.4 megabytes. Now we improve it to be like 10 megabytes to serve the same request. I forget to explain why the garbage collections uh, won't help in this case. Okay, so the garbage collection is taking a look at the object level. So it's looking this context as one object. So when you wrap this context with another keys and value, the garbage collection sees that this object is getting bigger and bigger, but the main idea is that this part of the code still accessible, which means you can use h.context and do something else, which caused the garbage collection not to free this part of the memory, because if freeing the memory is mean the data loss, right? So in this case, the garbage collections won't help. So that's why you have to manually profile the your applications and fix these problems by yourself. Okay, so that's it for the memory profilings in goals and some of the garbage collections. Okay, hope you learned something new. And the key takeaway is that uh, to minimize the memory leaks, you shouldn't use global variable. Okay, and uh, the memory profilings or the memory related issue is hard to trace it back, because uh, you seeing this graph, it doesn't mean that this part of the software is actually have some problem. So you have to have the background knowledge in many aspects to to be able to trace it down to the root cause. Okay, and this task is actually cost you very long time. So I have an experience that I have to do the memory profiling is cost me the entire week. And just just so you know that the problem may be hard to find, but the to fix it is very easy. Okay, as you can see that I can just like replace this part of the code with declaring a new variable. Okay, so it is up to the business also that it's gonna worth it to invest the time to fix these problems or not as well. Okay, so that's pretty much for this video. Thank you for watching and hope you learned something new. See you.